This is lesson 5.5 in pre-algebra called Similar Figures, and this is just kind of a continuation of the whole proportion thing, because if we have figures that are similar, then their sides, let's say we're talking two triangles, they're similar if their sides are proportional. So for example, if I have a triangle and I tell you that they are similar, and I say this one's 24 and this one's 28, and this triangle here is 6 and 7, then the ratio between the two is going to be the same. So let's say that I looked at this side and this side, 24 to 6. If they're similar, then 24 to 6 will equal this to this. 24 to 6 is 4. 28 divided by 7 is 4. So therefore, they're similar because their proportions are the same. And that gives us an opportunity then in order to find out let's say the unknown sides. So let's say that we don't know what this is, but let's say we know this is 5. Well, if they're similar, and they need to tell you they're similar before you can just make that judgment, you can compare this side to this side, x is to 5, as, and then it doesn't matter which one you do. You could choose 24 over 6, or you could have chosen 27 over 8. It doesn't matter, because if they're similar, it's going to work. And then you cross multiply, and then 24 times 5 is 120. Divide by 6, divide by 6, x equals 20. So this length right there is going to be 20, since it's similar or proportional to that one. Now you can have all kinds of other figures in order to do this. The example that they give you for example 2 is they give you the size of 2 video clips. So they have the one video clip this big, h, the height, over 320, and they have this one as 120, and the length is 160. So we're going to compare these two, and then we're going to compare these two. Notice the h and the 320 from here are on the top, and then the 120 and 160 are on the bottom right here. So make sure you do that. Okay, so then we cross multiply, and 320 times 120 is 38,400. Divide both sides by 160. Those go away, and h equals 240. So that means that the height of this one is 240. So they're similar. The ratios are going to be the same. Now, when you jump up to example 3, now let's jump to example 4. And this works really well, this concept, when you're talking about being able to measure the height of things. Let's say, for example, that you're standing here and you have a tree here that you're curious how tall that tree is. Well, we're going to use similar triangles, proportions, in order to figure out how high the tree is. So we know the tree is this tall. We're going to call it x, because that's what we're looking for. The sun is shining from back here. So we've got a yellow sun, and it's shining, and it makes a shadow. And let's make the shadow blue here. So it casts the shadow of this tree. But it also casts a shadow of you. And a couple things that we need to know here. One is we need to know how tall you are. And let's say that you are 6 foot tall. And then we're going to measure the shadow from here. Let's do it in red here, from here to here. And we find out that that shadow is 8 feet long. And then we measure the shadow of the tree. In this particular tree, the shadow is going to be 40 feet long. Because it's a big tree, so the sun's shadow is going to be bigger. So let's look at my proportions here. The shadow of you is 8 feet over the shadow of the tree. That equals your height. Again, see, notice I've got you and you is 6 feet, and the height of the tree we don't know. But I can cross multiply and get 8x equals 240. I divide both sides by 8. 240 divided by 8 is 30. So therefore, I just discovered that the tree is 30 feet high, based on you not even leaving the ground. All you had to do is measure the length of your shadow and know your height, measure the length of the tree shadow, and you could find its height. So, kind of a cool way to find out the height of different objects based on the shadow that they cast. And if you look at example 5, they've got a violin. And this violin is said to be the entire length of the violin is 24 inches. So we've got 24 inches. Okay. While the body length is 15. So it's saying that even though the whole violin is 24, from here to here is only 15. Now we're going to look at a cello, which is just a bigger violin, I guess. And it's telling us that the entire thing is 48 inches from end to end. What they want to do is they want to have you determine how far the body length is from there to there. So we're going to call that x. So we know that we have 15 to 24 with the violin, and that equals x to 48 with the cello. So body length of the violin to the body length of the cello, total length of the violin, total length of the cello. Now I just cross multiply. So I get 15x equals, I get 24x equals 15 times 48. And 15 times 48 is 720. Divide by 24, divide by 24. Cancel those out. And our 720 divided by 24 is 30. So, our body of our violin is, or our cello is 30 inches. So that's it for lecture 5.5.